Hey, it's 2:15 in the morning. I keep doing these really late at night. So, let's see. Um, I'm gonna think I'm gonna go through the entire show tonight, or entire. Oh, good, that's working. So I changed the XNest. It's a higher resolution one now, so I should be able to fit more things up here. Yeah, it's not bad. Let's see. So, let's just go to my script. I made the conclusion that I'm going to be going to the library tomorrow, which is, I don't know, what's tomorrow? A couple hours, I mean. There's a couple notes here of things that I'd like to integrate still, but I haven't yet. But I'm just gonna try to go through it all the way and see what happens. So, oh yeah, there's some nice new things if you haven't noticed it. So now, all right. So this is Linux's microcomputer predecessors pre-1996, also known as Y-Linux. I value accuracy, so if you find any mistakes, I built something for you to correct me. I value accuracy, period. If you find any mistakes, comma, I built something for you to correct. Let's just try this again in a way that I'm not going to do that. So where are we at? All right, that's fine. All right, this is Linux and its microcomputer predecessors pre-1996. I value accuracy. If you find any mistakes, I built something for you to correct me. You'll also find the script I'm reading. This is a general talk, so here are some of the players for our 20th century journey if you haven't met them. Let's warm up the time machine. We all use Linux even if we don't know it. Whenever you see a machine reboot at a grocery store, you're like, oh hey, there's that penguin again. Linux has arguably become the most ubiquitous operating system. How did that happen? The story usually given is an undergrad posted about his hobby project and a bunch of people helped out. Wait, a college kid with a hobby project started a computer revolution by posting? That's absurd. What about these other things that existed? These are only the Unix-ish ones. Oberon by Pascal's Nicholas Worth is from 1987, and there were other ones I found in the back of magazines and long-forgotten Usenet posts. They didn't even make the deck, but these did. Here's various commercial efforts. Some of these are complete systems, others are kernels. The lines are between the first and last release. The point is Linus was not shouting out from the wilderness. There was a vibrant Unix on the PC ecosystem that predated him substantially, an industry which hasn't had lasting impacts. Products such as Xenix and Coherent were hot stuff at one time, but now are the works of Ozymandias. Look on the timeline, ye mighty, and despair. That's because this guy, Kangaskhan Khan the Unix War. I can only find one commercial Unix without hardware attached to it still around. Xinuos UnixWare 7 Definitive 2018, which last release was actually 2017, and that's it. It's deader than dial-up. But Mr. Mackenzie, there's more to the story. What about the BSD lawsuit? Well, what about it? BSD has a long history stretching back to 1976. The two names for our story are a husband and wife team, Bill and Lynn Jolitz. Why didn't that win the Unix war? Well, this is usually given, but I'm not persuaded. BSD is much older, and in an interview with Bill Gillett in 1994, he said he started working on 386 BSD when the 386 came out in 1986, even though only something called Net 1 and Net 2 weren't released in that interim. Also, there were 5 lawsuits that held up BSD in court for over a decade. Did that affect its development? Okay, let's assume that there was a 2-year hold on BSD, and then we should go over to, say, Usenet and see a fair amount of silence during this time period. But in fact, we don't. This is just over 2 days. It was lively and vibrant. There's no evidence of any chilling effect. The highlight post is an update on a lawsuit amidst a bunch of articles talking about progress and bugs. I mapped out the velocity of 36 BSD Usenet articles and tried to see if there was any change and correlated with the court cases. And although I am not a data scientist, they looked completely unrelated. Lastly, there's a number of articles across the... Yeah, actually, I redid that, and I would say velocity of... I did BS386 BSD and BSD386, but let's not leave that out. If somebody asks, I'll say yes, I did that one too. Lastly, there's a number of articles across Usenet with titles like Linux 386 BSD, where people compare them. Although many include minutiae such as specific hardware, none talk about the lawsuit. So I have to reject the hypothesis that BSD was held back because there's no contemporaneous evidence. Tell me how wrong I am, go to the URL and denounce me at your leisure. Regardless, Linux has become at least a few orders of magnitude more prevalent than BSD and eclipsed all other Unixes. Why is that? I present two possibilities: the great man theory and a social history. The second is harder. Let's try the first. That looks easy. It says some glorious thing happened, but you can't do it because you don't have the right genes. Unfortunately, that isn't useful unless you enjoy sulking about things you consider flops. But you're all rock stars, right? Let's look at the second. Using the power of syllogisms, mere mortals did this. We are mere mortals, therefore we can do this, but only if we know how. The first is a much shorter speech, Carlyle-style hero worship about how great men should rule and others should revere them. I could have made a gushing mystical biopic. However, we've got a much harder job. Chapter 2. And to do it, we must have defendable and falsifiable hypotheses. But first, here is some more jargon. I can remove this bold thing right here because that is gone. Perhaps Linux was the second act of the personal computer revolution, personal software and personal hardware. If the central will not hold, things fall apart, and mere anarchy is loosed upon the world, we might as well make it productive and get nice software out of it. And get some nice software out of it. Maybe if Unix needed a pool of hackers to build it on cheap computers with a robust communication network and avoid bad actors taking advantage of their generosity. Maybe. There's also the maybe not falsifiable thing I talked about. Number one, Unix was thought to be really complicated. Actually, it was seen to be quite elegant and simple. The Unix source license was $200,000 in the 1980s, so of course it was complicated and magical. But that was marketing. Even 386 BSD, 20 years into Unix, was done by Jalitz as a husband and wife team, just two people. Number two, community-based programs was thought impossible. Nope. There's an organization called Share who came up with the Share operating system in the late 50s, which was community developed. This was eventually structured closer to a BIOS cooperative. Share was eventually structured closer to a BIOS cooperative. To see how it worked around the birth of Unix, let's go to Computer World in 1968. During the past 4 months, Share has been working with IBM to define changes needed by users. When the company responded, 12 of 13 requests had been turned down. Well, IBM, look what happens to you when you ignore the users. Happens to you when you ignore the... Oh yeah, Share was Los Angeles based, so LA Pride, I guess. Speaking of things that happened before I was born, age and history. Although Unix started in 1969, the first paper was 5 years later. I've extracted 4 principles from it that will be useful for a journey. Leverage, don't invent. Doing beats planning. Needs, not desires. Use early, use often. Although each may have its flaws, together they form a cohesion, even a synergy, if you will. Unix was designed for a class of computers that died out, called mini-computers. They were an order of magnitude or two cheaper than mainframes, and also less capable. Well, at first. People wanted to solve their mainframe tasks on cheaper machines because that might have been all they had access to. Roughly every decade, a newer, lower-price computer class forms based on a new programming platform, network, and interface, resulting in new usage and the establishment of a new industry. That's called Bell's Law, and it's from 1972. As mini computers came on the market and became more powerful, Unix was there to leverage them to service people's needs. These new machines provided new context for new software. These needs are not only meant as examples. The point is the velocity of computer progress went faster than people's needs. You could say it looks like computer performance increased as a square of the cost, and that transistors per chip doubled every 18 months. This is called Grosh's Law and Moore's Law. Together, it meant the industry eventually ate itself through a multi-decade line digestion. However, when new things come in, the people who get there don't get there easy. It's okay, though. Some of us are crazy and prefer it. AT&T was under a lot of legal restrictions, and because of that, Unix was initially distributed as if it came out of the back of an unmarked white van. The chart on the right was part of the standard presentation deck for early Unix, saying that you're on your own. Think of the adventure, the excitement. But who are you catering to with such a message? What will be the behavior of these people taking the project? What will the behavior of those people... Where will the behavior of those people take the project? Whatever. I will underline these things that I'm tripping up on. It's not about welcoming everybody or doing everything. With any of these efforts, you have to ask yourself who you're bringing to the door and what kind of behavior you're expecting. That's what separates a library from a soccer field. For example, Linus, October 1991. You also need to be something of a hacker to set it up. So for those hoping to an alternative to Minix 386, please ignore me. It is currently meant for hackers interested in operating systems and 386s with access to Minix. Maintaining focus is about intentionally, not incidentally, but actually intentionally choosing to ignore. You have to be a clear signal amongst our noisy world, because you have to know what you're doing. Unix was initially introduced through engineering and technical people, and not through the conventional decision makers. But it worked, and by the early 80s, Unix was mainstream. As both consumers and producers of Unix multiplied, the suppliers differentiated themselves by succumbing to the trappings of usual competitive markets. You can call this enclosing the commons, trying to take ownership of groups and commonly held things by setting up barriers so you don't lose them, by thus locking them in and growing your base by trying to look special, by trying to be special. Unix had infected everything from workstations to mainframes. Unisys, one of the mainframe makers, had an article in September 1987 issue of Computer World predicting a tripling of Unix sales in that year. The problem with the infighting goes back to the chart with the various blobs about computer classes. The threat is almost always coming from below. In this case, it was Microsoft and microcomputers, and not Nixdorf's Unix on an NS32000 versus clicks on an Intergraph Interpro. In 1985, Microsoft argued that their Xenix Unix, which had an install base of 100,000, would be a multi-user version of DOS. In 1987, they said they didn't see it competing with their plans for OS2, which at the time was seen as a successor to Windows 1.0. I know things changed, specifically that December with the introduction of Windows 2.0, and later with Windows for Workgroup and NT. That was the real threat. Anyway, Xenix required 12 360K floppies, which was seen as bonkers. I will then show the floppies in my hands. In case you're even younger than me, a 32GB micro SD card is about 93,000 floppies, 190 meters stacked end to end. That's like a 2.5 minute walk. All the storage now on the side of your thumbnail and costs as much as a taco on the west side. Anywhere, software distribution used to suck. Speaking of Microsoft, that punch tape is how they distributed BASIC for the Altair in the 1970s. It took about 20 minutes to load, and of course it wasn't then stored on disk because the Altair didn't have one. Just keep the computer on if you wanted to use software. It's also worth noting lower right. That's called a type-in program. Software used to be distributed like this as multiple pages of hexadecimal. I am serious. No, I'm serious. Look, this is MLX format. They publish listings like this every month. For years, you typed it in. There was no electronic reader. You could see some of the basic code from the first page, and it's not pretty either. The QR code is this game running on an emulator in your browser. You can just scan it and tap it on your phone. No typing required. Anyone want to scan it, give it a try? I'll leave it up for a few seconds. You could only use software that you have access to. For many people, that meant retail or mail order channels. You could also copy a floppy from a friend. The bottom two methods had consumer overhead. For dial-up, you usually had to pay an expensive phone bill, and for internet, you probably didn't have it. This meant most people were only exposed to the top three groups, and thus it was difficult for smaller developers, and especially non-commercial ones, to get their software to the message. Quoting Marketing High Technologies, Bill Davidow, 1986, it's not a product without a distribution channel, or in Linux's case, a distribution. The technology, paraphrasing. The technology may have the potential to address the needs of many, but without specialist redistributors to put it in the hands of those customers, it will not succeed. Products are sold through distribution, not to distribution. I need to jump forward to the why Linux question here for a bit. While this diagram is up, Linux had high accessibility of the install media. Not only were the websites that would mail UCDs, not only were there no, I mean, this is correct. For $1, but you could find them in a coffee shop. That's my rule, is to underline the things I'm tripping over. Libraries and attached magazines to the grocery store. Filling up a CD with a Linux distro and heavily cribbing a bunch of well-written how-tos was cheap content for a magazine producer who just wanted to get an issue out. But let's go back to the problems. Depending on the distribution channel, updates had a different logistics and complexity, especially when considering updates from outsiders. For instance, if you wanted to update the retail Lotus 1, 2, 3 and have your changes appear on a shelf at Circuit City, you'd probably have to do it yourself and get arrested. It would have been fun, though. Once there were online networks with the storage and communication necessary to unlock multiplayer online mode for the software development game, a new form of writing software was created. Yaki Benkler made up the term Commons-based peer productions in 2001 and wrote a book about it called The Wealth of Networks. Let's go to Linux 1991. I've enjoyed doing it, and somebody may enjoy looking at it and even modifying it for their own needs. It is still small enough to understand, use, and modify, and I'm looking forward to any comments you might have. I'd like to hear from you so I can add your software to the system. Adding things to Minix, from Minix to Linux, huh? How do contributions and updates work? Unless you can answer these questions clearly, progress will be slow, infrequent, and inefficient. Everyone has to agree on the terms and feel welcome, otherwise they don't come around here no more. So GNU made a Rooseveltian list of 4 software freedoms to define free software. But for our purposes, we're only going to talk about the horizontal software development, or what I call adoptive, because it's not just license, it's organization plus license. Essentially how easy it is for modifications to become integrated and in the same distribution channel, and other people to become a distributor or to share your product. You need not only a decent legal structure, but a software organizational structure that affords this, and an open shop that permits anybody to come in. Eric Raymond spoke to this in his seminal work, The Cathedral and Bazaar. Here is the Cathedral model, which is tall, in which source code is available, but development is restricted to an exclusive group. Contrast this with the Bazaar model, which is flat, in which code is developed over the internet in view of the public. The vertical lines here, from permissive to restrictive, is a general continuum. Public domain is seen as too permissive in the eyes of GNU because you can relicense and reprivatize things. I've also read that copyright and GPO are different from each other, but I never went to law school. If you zoom in, you can see non-computer things. I'll go over a few. Bottom right is facts. People ought to be really hesitant to modify facts, and they're public domain. Above that, you have most religions. Anyone can preach a good word and start a congregation, but at least in principle, that the texts are sacred. As we go up, we get jokes, recipes, human language, and at the top is folklore, which changes readily. As you move to the left of public domain, you get Wikipedia, which anyone can edit. On restrictive adopted side is social media. Anyone can contribute, but the platforms retain a bunch of rights. Classical commercial software is down in the hesitant and restrictive camp. The pink stuff is Linux related. Minix is down next to freeware and GCC in the hesitant category below the pool label Unixes. Except for social media and Wikipedia, all of this is early 1990s and not 2024 accurate. Speaking of the past, let's go to the introduction of Minix. In 1986, commons-based PR production wasn't feasible. People didn't have the internet in their pocket like you do. Because of the prohibitive logistics around software distribution updates, especially customer-initiated, Minix could only be a cathedral. Also, it's worth noting it was a product of Prentice Hall, who wanted to sell textbooks and instructional material for Tannenbaum. So here's the relevant parts from the announcement. It's not public domain. However, the publisher does not object to people making copies for friends. This is SneakerNet. If you want to sell it, which is the 2 categories above SneakerNet, retail and mail order, you need permission. In his book, you will find a postcard that you can use to order the software. There's our mail order again, and he says he doesn't want to copy it a bunch of floppies, as in do SneakerNet. Now, I also mentioned Minix was adjacent to GCC. Well, what's up with that? GNU was also a cathedral. Here's an example from an early GNU bulletin, 1987. We can see it as listing out different distribution channels as they solicited funds to pay programmers to write more software, like a software engineering firm does. They played a second role as a provider of copyleft and eventual software under the GPL, which came out a few years later. Every bulletin had a growing list of software by others that you could order basically at cost. You could get Net2 BSD and then BSD 4.4 Lite from them until 1995, after which they said they were working on Linux distribution, which never happened. It came from below, but they didn't see it. As far as distributing free stuff, there's precedents, such as this one from 1976, trying to be a repository for public domain software from smaller producers, such as Code published in, say, Dr. Dobbs' journal. Some assembly programs ran over 40 pages long in that journal, that publication, that you, of course, were expected to type in yourself. So people were looking for a more reasonable solution that didn't cost much, but not all pieces were there yet. All of these things required labor coordination and resources, and how you chose to instrument those made some things more possible than others. I feel like I used resources twice here, but I should probably just underline it. Look back at it. Ideas are bizarre even when implementations are cathedral. For instance, there were many graphical... Oh, there's no transition there. Transition... For instance, there were many graphical desktop computers, even though each one was a proprietary restricted project. The structure of desktop computers operated in the adaptive space. Pretend we have a concept of a free operating system. We may not get all the parts right the first time, but the Platonic ideal exists. Well, kind of. It is as much a contemporaneous invention as anything else, as a pale, true thought suspended in our life streams. We can go back to Vannevar Bush's Memics article, as we may think, in The Atlantic from 1945, see the split of what we now call many things. Unlike products, Platonic ideals are collective projects owned by nobody. They are permissive and adopted, not static abstractions divorced from human influence. They are ideas manifested from context. The map is not the the territory, and in our industry, we're tasked with creating both through pure thought stuff. What a responsibility. We better get organized. This is about complexities of building software, not about electing people. You may have heard that commercial software began with Bill Gates' open letter to computer hobbyists in 1976, where he denounced an economic distribution of Altair Basic because he can get paid for each of the copies. That's not really where commercial software began. In the mid-1950s, software was in-house, coupled with hardware or contract-based, as you can see in his 1959 ad for a programmer from Punch Card Data Processing. But the version of commercial software that had built stuff you purchased, that's it, for a computer you already owned. That's the thing I need to get rid of. Has existed since at least 1960s. No, really, there's another falsifiable thing that I want to go over. Bruce Perrin's chapter on open sources, Stephen Levy and Hackers. They allude to this Garden of Eden in the past from which we have fallen where all software was free. Really? Well, no. Here in 1966, claiming commercial software was a $100 million industry. And in 1969, 11 companies worth at least $100 million got together to fight off not-for-profit efforts. They got together to form a trade group. The manufacturers bundled software to lock in their customers, like Microsoft did with Internet Explorer. It was as free as Windows is on a laptop you buy. People were trying to DRM and patent software back in the 1960s. Maybe there was some idyllic Valhalla in a bubble known as the MIT Artificial Intelligence Lab, but the real world was up to the same tricks as they are now. Anyway, debundling happened in 1968 and 69, vendor by vendor, and Unix arose from primordial soup and is one of the oldest non-mainframe software that is still recognizable today. I say recognizable because the family tree looks like a European dynasty. This Unix timeline chart covers a few years. This Unix line cut just to drop the charts. If you were to zoom in, you'd see Minix, MIT Trix, SunOS, the Mach microkernel, Xenix from the House of Free Software, AT&T, or the Kingdom of Microsoft. I'm still not a lawyer, but this is really complicated. Confusing. Not only does the source and binaries have different terms, but sometimes only certain organizations had access to them. For instance, if you were an educational institution with a pre-existing AT&T license, then you had access to BSD. So a version might have multiple parents, each with a different term sheet. It's a legal Habsburg. That's why a few slides ago there was a puddle labeled Unixes. Even the Unix term itself is a confusing mess. Raise your hand if you still think it's copyrighted by AT&T. Nope. Over 20 years ago, AT&T sold the copyright to Novell, who then donated to Open Group, which is now a standards organization. Some Linuxes have gone through that process, so Linux is now a Unix. Really? You're just finding out about this now? It's absurd. We need something with clean document history, a clear license, and easy answer to all these problems. So Linux and effectively all modern open source projects have this solved. All development is open, the history is well archived, and OSI approved licenses solve the family tree problems. This structure that's now ubiquitous as one of Linux's main contributions. Also, let's look at the internal politics of building software. In the Abstract Penguin slide, we covered the outside aspirational curve where things take decades and opinions are strong and many. Things like paradigmatic ways of doing open source software development took 20 years to develop because the longevity and applicability of the more abstract solutions is also on the same time frame as their implementations. But with that exists lower level Maslowian motivations, and keeping things there make them more actionable. Let's say my network card isn't sending out packets. We can say this bug is known, agreed upon, and demonstrable. So although it may not be easy, the labor path is traversable. Now a new network card comes out. I need it to work on Linux. That's a need. I can demonstrate and come to an agreement on what it would look like. Now I pretend I want to do something it wasn't designed. Now I pretend I want that card to do something it wasn't designed to do. That's harder to demonstrate and agree upon. To get that actionable, I need to pull the desire into the lower curve so that a development cycle can encompass it. It's worth noting the Tannenbaum-Torvalds debate of 1992 to illustrate this. Tannenbaum chastised Torvalds because it wasn't a microkernel, and Linux was exclusive to the 386. I want to rephrase that. I don't know that one. GNU Hurd was a microkernel. Really, Linux was in the lower curves, and Tenenbaum was trying to pull it up to the higher level curves where things move far slower. GNU heard was a microkernel approach. Stallman claimed in the early 2000s that's why it was taking so long and it wasn't very stable. The point is the higher level curves are unlikely to succeed except as superstructures of the lower level functions in the same way that our asymmetric approach to Platonic ideals happen on a back's incrementally more appropriate implementations, which is why you can snake a line from the 1950s IBM Share organization to GitHub. Through the process of clarifying the aspirations, they get moved to the concrete because they become material needs and bug problems. The clarity of the present stands on both the triumph and the wreckage of the past. You don't need to know the history of the spoken language or any other system in order to use it, but it doesn't hurt. If you could understand the price of everything, you'll know the value of most. I found both an article and an advertisement from May 1990. Sun says they have a cheap $6,700 computer. Here's a PC at about 1/10 the cost, which is fine if you can do some of the same things. Historically, that answer had been no, but referring back to the chart with the needs and computing classes, this dynamic was likely to change soon. The 386 had many technical features that made it more appropriate for Unix-style operating systems. I mean, this is true, but I don't want to underline it. But that's not the kind of price, that's not the only kind of price there is. There's also the price of times. This is a conceptual and not a quantitative graph. Essentially, Windows is the easiest to get up and running and going, but let's say you want to do something like batch convert a bunch of files or sort the contents, pick a field, extract the values, do some operation on them. These things get hard fast on Windows. Early on, 386 BSD and its cousins were a pain to set up, but they had networking before Linux. It was a more sophisticated project. However, there were fewer people working on it who tended to be more experienced, so they were busy and expensive. Linux was mostly students, which are famously cheap. It was also heavily hobbyist-oriented, which usually meant the systems were more hackable, while the other Unixes, they presumed you had something important to do. The more difficult and time-consuming it is for a customer to use an information system, the less likely it is to use that information system. That's Calvin Moore's 1959. As the complexity of the problems become more intractable, the approachability of the lower levels of the internals of the system become increasingly important because people tend to use the most convenient method in the least exacting mode available and stop as soon as minimally acceptable results are found. That's a principle of least effort. Hackers tend to build worlds where everything is possible, but nothing of interest is easy. Alan Perlis called this the Turing tar pit in 1982. Pulling yourself out of the tar pit from a capable to usable system requires some engines to push it forward. Our wordy commons-based peer production model from before can also be seen as prosumer, a producer and a consumer put together. It's often used in social media where you're consuming other consumers' productions. Here our engine is problem-solutions integration, which keeps us in the bugs needs development cycle. With the bizarre method of software development, the changes reflect back quickly, which means that newer users have fewer problems with their different hardware, so that for other people with, say, my network card, it would just work. But where do you find the people to do that? Well, you have to build armies, of course. Large networks are important. Their utility can scale exponentially with the size of the network. The number of combinatorial subgroup participants from these larger collections grow more rapidly than the original utility of the groups that joined. That's Reed's law from 2001. I'm going to underline that. For example, my friend and I start using Linux. I have a network card that doesn't work. I now join the subgroup of people becoming a we. That needs that card to work. This only becomes an engine if you have the right people to complete the cycle we talked about. The lowest level here are enthusiast developers and bug fixers, followed by the curious hobbyists, and then the business needs and people like the power plants and airports that can't have things fail. I would say the first level here. Arguably, one of the failings of the early BSDs is that they were too lopsided on the upper steps, and thus couldn't get the very virtuous cycles moving with enough velocity. I analyzed the email addresses of about 2.5 million Usenet posts over a 2-year period, and you can see there were almost always more commercial emails for BSD and more educational ones for Linux. So even though their general trend was ascending the staircase, Linux had more torque from the bottom groups. I call this a Linuxist revolutionary theory. The hacker vanguard forms a coalition with the personal computer proletariat, and a business-oriented bourgeoisie becomes interested and finally prohibited assiduous aristocracy is able to use it. There is one last type of price, and that is that of expertise. Whether it's your own or you're fronting some cash, it's expensive. You could roughly assign a utility function as the capabilities divided by the effort required. Sometimes both capabilities and effort increase over time. Blender, for instance, is highly capable software, but it also takes a lot of expertise to use effectively. Many mobile and web apps, on the other hand, actually remove power user features over time and make the product require less effort while also making it less capable. Still, other software APIs and frameworks have Fred Brooks' second smell effect. They have a new version that's far more difficult to use and leads to inferior results, thus being an inversion of the graph and decreasing the utility of the product. For example, let's talk about the multiple arrows. In order to get a larger user base, you need a diversity of capabilities requiring a diversity of efforts. Linux was able to achieve this by outsourcing the actual packaging of the OS through distributions. This is another insight about bizarre software model. Since the entire structure is more flat and the structural organizational barriers are mostly removed, as markets naturally subdivide and form, they can quickly and readily be addressed. Because we're doing social history, I'll use critical theorist Mark Hughes' idea of de-radicalization. The dominant structure, say markets, subsumes the novel. However, because in bazaars people can self-organize, they beat it to the punch and move faster than the market force, which is why open source decoupled structures are more dynamic and swift-footed than commercial approaches. Here's a chart from Innovator's Dilemma describing different strategies that can be taken as technology gets better. You can see you can generally either push up market to higher end customers, which are the two top staircases, or you can stay with your existing customers, which might be the lower steps. However, because the horizontal development of Linux and the existence of distributors run by multiple organizations, it was able to do multiple strategies at once. Not only these, but any others that have been left off the graph. A few slides ago, we saw how Linux was a horizontalist, bizarre approach to software internally. Let's look at the implications externally. This chart is taken from Andy Grove's 1985 text, Only Paranoid Survive, describing how the industry moved from one-stop shop verticals to a horizontal structure. If we put this in the aspirational space, this can be viewed as part of the same decoupling superstructure as what the mainframes were doing in the late 1960s. The premise of the transition was a book called The Coming Computer Industry Shakeout by Stephen McClellan in 1984, quoting, "As software gains ascendancy, a new word will arise to characterize activities of the industry. The key word will no longer be customization, specialization, or market niche. The new word will be integration. Systems integration will be the most sophisticated and difficult task computer companies will have to undertake. That quote being 4 years old gives the privilege of seeing what happened. Essentially, 4 strategies were developed to tackle the problem. The first is to impose a vertical by claiming you're the standard, but in practice only one player can do that, so OS2 died. Apple took a different route by being its own vertical, and Linux had to push the wheel out of the tar pit and need enough people to do it. Luckily, timing was on their side. When the internet was mostly accessed at universities, September annually brought in a flood of new people that had to be coached. However, as residential internet grew, the old guard termed 1993 as the eternal September, the beginning of the mainstreaming of the internet. For this to happen, cheaper ISPs and web servers needed to exist quickly to support users. It's important to note that Linux was prima facie hobbyist and personal use oriented at the time. Linux Journal had articles in 1984 about its web server and running ISPs. However, 1984 texts such as, contemporary. Linux getting started, unleashing the workstation in your PC or plug-and-play Linux from 1993 were in the lower 2 steps of our staircase, hobbyist and personal. The early Slackhorn SLS distros from the time also didn't include web servers or tools to run a business. The first people in subsequent use case steps didn't get there with clean off-the-shelf solutions. They play the scout role, clearing the road for the army to roll in, which is why the web server book in 1995 now includes Linux. Another benefactor of the eternal September is attributed to Linus's law. Given enough eyeballs, all bugs are shallow. All bugs are swallowed. Let's look at the various eyeballs. In the first term slide, I said that Linux was mostly built by college kids, and here's some evidence. After the first post in October, after first releasing, Linus got some help from a local friend, but by November he had contributions from Hong Kong, MIT, and University of Utah. In December, contributions came in from Calgary and Berkeley, and then Colorado and Maryland students coming in January. So far, everyone is under 25, and as I said before, there becomes an increasingly pressing need for a solution like Linux to solve new problems, and those needs more or less persist to this day. Apple is vertical, Microsoft is entitled, and Linux continues to climb stairs that have yet to be drawn. Here's a quote by Torvalds. "I think the timing was good. Even a year earlier, I don't think I could have been done, and a year later, somebody else would have had to do something similar." These 2 bottom charts show how Linux now dominates supercomputer and web server space. How's everyone doing? I hope you're still awake. Yes, that's typed on this sheet, as is this. I know this is long, so let's have some fun. If there was a storefront named Open Source, what would be displayed in the windows? In fact, let's do some interactive theater. We are a group of people in 1995 trying to bring free software to the masses. Our marketing director just told us about, I need to scroll down this window instead. With the 4 Ps, product, price, place, and promotion. In order to have a figurehead for the free software movement, we need to find a piece of free software that qualifies these conditions. It should be easier to try, acquire, and understand. It should have a low price of time, money, and expertise. I appreciate this suggestion so far. These are all excellent examples of free software. I especially like the elevator pitch for Emacs org mode. But before we settle on a project, I'm wondering if we've left anything out. Any suggestions from the audience? Oh yes, you sir, the man who I've known for over a decade. Oh, that's a great idea. Maybe Linux can be the window dressing of the free software movement. Or how about this? I have a better idea. Let's make an alt copyright pipeline. We have the low effort things for curious PC users to try. Then we would tell them the beliefs of our communities and get them to up their commitments. As they do, they will become more familiar with the projects which take efforts and expertise, get more involved, and become an advocate for them. Over time, some of these people aid us, if we're lucky, we'll just aid us in reporting bugs, determining needs, and implementing desires to move our aspirational projects forward to make it more tangible. In order to do this, we must be a welcoming community, by necessity and also because we brought in the right people. So, that's how it happened. Oh wait, how do we do it again? The final boss. Geoffrey Moore proposed this graph in his work Crossing the Chasm in 1991. Made. It proposes that as commercial products are introduced, made. It's fewer syllables. It proposes that as commercial products mature, users with different behaviors and expectations come around. There's 2 holes in this graph. This first group is people. The first group is people who are aspirational and have a high tolerance for impracticality. They are willing to go the extra mile and make something work. Then there's a hole. In the graph on the right, with the electric car adoption in Norway, you can see that small slump, the first circle. The next group is enthusiastic about the possibilities, but want a lower effort, time, and expertise cost. But prefer a lower effort, time, and expertise. Yes. Then there's a really big hole. The next group is a difficult one. They are looking for a working product and don't want to be hassled with inconvenience. That's the yellow circle in the graph. Yeah. Difficult one to reach. All right. I think that's better. Yeah, I don't like how the thing was phrased before. Anyway, I present Crossing the Open Source Chasm. The first group are passionate hackers trying to claw at the aspirational curve and bring it down to the bugs and needs. If they can keep their passions going long enough and make sufficient progress, then perhaps the music makers will come around and recruit more passionate people to enlarge that base. That's the first pipeline. If the engine between the passion and the enthusiast can be maintained in order to get to the problem-solution integration wheel, the project can get pulled out the Turing tar pit, and if the software capabilities divided by the effort demanded yields enough of utility ratio, then a pragmatist will become interested and the chasm is crossed. But it's important to keep the pipeline well lubricated because you'll be facing new challenges and use cases, and you'll need a few of those new users to slide around the responsibility graph in order to grow the coalition as the law of division takes hold. Back when we talked about Platonic ideals being permeable, bizarre superstructures occupied by various executions, I said that the clarity of the present stands in both the triumph and the wreckage of the past. Sometimes for a city to become great, it must first be destroyed, so that a new generation can seize a dream and try to execute it better. Failure unbinds us from commitments and gives us permissions to kill our darlings and failures and the passage of time. And do a page one restart by naturally creating the space for us to try again, but only if we retain the liberty to do so. Here's a few historical examples. Does anybody know what they are? This is new. That's a Bard televisor, which is an early mechanical television. This is the Cook and Wheatstone telegraph, and this is an arithmometer, the first practical office calculator. That's from the 1800s. Strong IP enforcement on strong vision diminish the chance of success. You must let go of that which you love the most. You may get the vision right or the execution or the timing of the team, but probably not all at once. Facebook, iPhone, Google, Amazon, they're all iterative executions on larger ideas owned by nobody. If you're working on a thing or have a dream and it's just you, then you are definitionally on the very left. You could argue that for certain use cases, Linux took over 20 years to cross a big chasm, and for some things, desktop publishing, digital audio workstation, photo editing, or social media, the free software chasm is still not crossed. There needs to be a certain kind of affection for the people, their needs, desires, and aspirations, for these to eventually succeed, for, say, the GIMP to overtake Photoshop, the commitments to others, lowering the responsibility chart is key, because that's how you get the new recruits. Yeah, I don't like the word lower. Yes, with less responsibility. So whatever you're working on, it will take years to manifest differently than what you thought. You have to not have codependencies with it. That will foster resentment, anxiety, and low self-esteem. Really, you'll probably just become susceptible to the great man theory. If something is dying, maybe that's a fire you need to rebuild things. Listen to the needs and desires of the idea. Do one thing and do it well. Work together. And header text streams, because that's the universal interface. This is actually the Unix philosophy by Peter Sallis, but I'm serious about it. Good software advice is also good people advice when building software. Let's go to Tracy Goddard, Solve a New Machine, 1981. Looking into the VAX, West had imagined he saw a diagram of DEC's corporate organization. He felt that VAX was too complicated. He did not like, for instance, the system by which various passive machines communicated with each other. There's too much protocol involved. He decided that VAX embodied flaws in DEC's corporate organization. The machine expressed that phenomenally successful company's curious, cautious, bureaucratic style. Again, I have to underline everything. Churchill said we shape the buildings and they shape us. However, our buildings are different because the programmer, like the poet, works only slightly removed from pure thought stuff. He builds his castles in the air, from air, creating by exertion of the imagination, or so says Fred Brooks. Regardless, some wrecking balls for code are cheaper than those for concrete, so don't be afraid of using them. Here's another Unix philosophy. This time, we'll think about it in terms of people. Make it easy to write, test, and run organizational efforts. Interactive use with humans instead of batch processing. Make do with smaller teams. You'll need all the engines I talked about to get over the chasms and move the projects forward. Organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. Melvin Conway, Datamation, April 1967. We studied yesterday to create a better tomorrow. The future is ours to make. Probably. And that's it. Timing is 42 minutes, which is... I was not motor mouthing, which is good. I'm relaxed, which is good. I could go slower still. There's a couple of things here that I think are still just verbally complicated and diffusive that I'll need to change. And there's a couple words here where, like, if I just change it slightly, then all of a sudden I wouldn't, like, I'm a picky nerd, and if I heard some of this stuff, I'd be like, that's not quite right. And then I, like, lose respect for the speaker. I'm like, he doesn't know what he's talking about. But, so I'm trying to do that same thing on me. And I'm like, well, if I could just change a word slightly, then I don't have that same kind of semantic complaint. Whatever. Let's see, what else have I done? Tomorrow I'm going to go to Lapple because it looks like they do have the Unix for it. I did call them today. I got up at like 2 p.m. in the afternoon. Oh yeah, I think I said that already. Yeah, I was so exhausted. I can't really do this stay up all night thing like I used to be able to. That's part of getting older. let's see. I added these things. So last night I was like, oh, I need more examples. And then I thought about it a good amount. And I was like, we removed the failures thing. And as long as we're like, things by time. And each of these are like, there's a different story. So the arithmometer was actually extremely popular technology for, I don't know, 50 to 70 years. This is a mechanical calculator. There were millions and millions made. This was as common as the modern sort of desk calculator, if you will. But, it's long forgotten. People throw it away because you don't need these anymore. So you only find them in museums. This is the Cook and Wheatstone. It was in a very early telegraph. And this actually is a counterexample to what I said. Because these two people hated each other and they fought over the copyright of this device for their entire lives. But that's what prevented it from actually really taking off. However, their protections didn't go beyond this underlying technology, which meant that you could then re-implement the idea of the telegraph using something else. So Samuel Morse's, which is a much more efficient method, was probably a result of seeing something like this and saying, oh, that's a really good idea, but these people are assholes and this thing really isn't working that well. So, they didn't claim a big enough kingdom to stop others. And maybe the fact that they were covetous on a small enough thing with their idea is what permitted the other systems to grow. I mean, that's kind of Nelson's issues too, right? Is that he was never open with it. He was always kind of a covetous bitch. But, Xerox was too, right? And let's not think that GNU isn't with their cathedral idea of the bizarre. So this is not real. This is positive, right? The more thing is to say, like, somebody with a good vision who's a petty little bitch, that's probably will equal success because they're going to be distracted with their little stuff over there, and they won't be able to grow the product, and so then you subvert them with more innovative designs. That's probably the actual mechanisms that's happening here. But I'm not going to do that because I'm an adult and I'm not going to do that kind of crap. Anyway, let's see what else is going on here. Oh yeah, this is cool. So I made this. So it's a bunch of different like magazine backgrounds that I found. So they got like QNX. The other day I was like, what the hell's Regulus? So I looked into it and I also found an ad for them. The AT&T, here's Cohan. This is Mark Williams. Was the company name. This is actually to a really interesting HP machine where it was like in ROM. So I posted it on Twitter because it was such a wild machine. I've never seen anything like it. And I read some reviews on it. It's very interesting. So here it is. Yeah, so it's got like a printer built into it. And this is HP UX 1.0. And it doesn't actually have a hard drive. This is burned into the ROM. So I guess updates would be tough. I don't think it had the technology to reburn ROMs. You're kind of stuck with it. Oh, also, it was not cheap. First 32-bit Unix system under 5. Okay, well, it was the cheapest one available, right? But still. Mouse is optional, so it's like saying, even at that price, yeah, they kept with that keyboard design for a while. I like this thing right here. That's like for cards and oh no, actually, on here, is that for this bezel? Were they doing like a Compact 1 thing? They must have been. With those clips. Look at those clips right there. Yeah, they were thinking about like putting a keyboard on the end of this thing somehow. Digital 1.44. Yeah, I've never seen that before. Anyway, that's what this thing is right here. This is the 3B2 AT&T. So AT&T made their own PC. It didn't really do that well. Where is it? There it is. And of course it ran Unix here. I just clicked on any random link, so let's just see it. Here's a modern version. This is the Blit terminal that Rob Pike did when he was a young man. And you can see AT&T right there. I wonder if the Unix is any good. I wonder if you like can get an emulator. I didn't even look. Yeah, it had this really weird red mouse. Yeah, so that's that one up there. SCO's Unix. This was actually out of an article. This was an ad. I just thought it looked cool. Unix operating system from PC to mainframe. Like I talk about that, so I decided I'd do it. User group was the first Unix users group, so that's why it's up there. This is just Usenix 4.2 BSD. That's fine. OSF was the Open Systems group. That was the alternative to Unix International. That was in some of the earliest drafts because I was pointing out to that part of the slide and I was talking about things in slides as opposed to just putting up a slide and thematically talking to something adjacent to it, which is kind of what I'm doing now. Let's see, what else? There was something I thought of that I didn't stop. What was it? One of these things. Very first. Oh, here. Maybe you can have a bunch of devices here in the background, that have the Linux kernel or parts of, a Linux system somewhere on it. I have that in the video that I made. Let me see the video. This one.
IBM has introduced Next Show Apollo Computer. Silicon Graphics introduced the Iris 4D60 Super Workstation.
Through the combination of graphics and Unix, the Blit has given me access to the power of multi-programming.
Unix started on some digital equipment machines and has since been moved to little
by an underbacking inside your TV and controlling the doorbell camera, recording your dinner delivering robot, which is also running Linux.
That are running Linux underneath.
How did this happen, and how can we do it again? Find out at my how did this happen, and how can we do it again? Find out at my how can we do it again?
Is that something I killed? I mean, I think
how can we do it?
Killed that one. Progress due to sustaining. Oh no, that's just straight out of Innovator's Dilemma. The NAT's out of open sources. The NAT's that's
find
the key
out
for crossing the open source chasm. So yeah, so this was this was early on, February 3rd. So yeah, that's what it looked like over a month ago. Yeah, lots of things have changed. It's what things are when you continually work on stuff. Anyway, what are we at? Still under an hour. Nice. I can go to bed because I have to get up tomorrow and go to the library, which involves getting on a train. All right. Zephyr. I don't quite know what they did. They had like some kind of, it was like some open house tech thing in Venice in 2015. And a bunch of companies had like this open thing, and they had this Python competition, and I won it. And then I got this t-shirt. I got a GoPro, which I sold. And it's so weird because I thought that like when you have those things, like that's part of like recruiting. And so I was like, okay, cool. I'm going to like sit down. They're going to have some conversation with me, talk about like what the thing is, right? Like that's why you do those types of things and have those type of competitions, is that you're looking for potential hires, like the HR department's doing it, right? But I went in and they said, oh, here's your stuff. Here's like a nice water bottle. Here's some t-shirts. Have a good day. And I was like, all right. I didn't mind. I didn't have any interest in, I don't know what they do. Wall Garden Brand System. I still don't know what they do. Total Walled Garden Transparency. What the fuck is this? That was back when people were doing a bunch of social media companies and trying to like, this is how you make money on all this stuff. And, this is like before cryptocurrency world and before AI and everything. So I don't know. I don't really know what they were doing. Oh, I guess they're still around. I guess people still use them. Yeah, whatever. Anyway, I wasn't interested in them 10 years ago, and I'm not interested in them now. But the shirts are nice, and they've lasted a while, so that's what the company is today. Zephyr. I mean, it's really comfortable. I sometimes sleep in a shirt. Anyway, talk to you later. Bye.